Hare Krishna. So today in this video we'll be going to discuss about the solution of question number 30. Before proceeding, you can pause the video for some seconds and go through the question. Next we'll discuss the solution. In the very beginning we'll discuss about the important concepts that will be required for solving this problem. Those are convergence in distribution, convergence in probability, and Markov's theorem. As in the question it is given, xn is a sequence n greater than equal to 1 where xn follows binomial n comma pn where pn belongs to 0 comma 1. We need to find a condition that implies convergence in distribution. That is, xn converges in distribution to 0 as n tends to infinity. We know a result that convergence in probability implies convergence in distribution. Now, one by one, we'll look into all the options and select which one is correct. But we will see all the options, not just the correct one. So the first option is limit n tends to infinity pn equal to 0. So whether this condition implies convergence in distribution or not, we will see. So if we take pn equal to lambda by n, where lambda greater than 0, when we do the expectation of xn equal to npn, because xn is a binomial distribution in comma pn, we found out that expectation of xn equal to lambda. And we know that when n is large and pn is very small, then binomial, we can approximate a binomial distribution into a Poisson distribution, where mean is equal to n into p. So basically xn converges in distribution to Poisson lambda, which is not the correct option. Limit n tends to infinity probability xn equal to k equal to 0 for each k belongs to natural number. If again xn takes value n with probability 1, then for any fixed k and large n, probability xn equal to k equal to 0, but xn clearly does not converges in distribution to 0. As we can see that probability xn equal to n will be 1, then it is xn is actually not converging to 0, right? Because n is not 0 and n is a very large number. For option C, limit n tends to infinity expectation of xn equal to 0. By Markov inequality, we know that probability xn greater than epsilon less than equal to expectation of xn by epsilon. Now, expectation of xn, if we put limiting value, then it is 0. Then probability xn greater than 0, probability xn greater than epsilon is less than equal to 0. I hope this step is clear. And also the probability by definition is greater than equal to 0. This is by definition, right? And from sandwich theorem, we can get that this, because probability xn greater than epsilon is less than equal to 0 and probability xn greater than epsilon is greater than equal to 0 also. Hence, the common value is 0 only. So by sandwich theorem, we can write this. And this is nothing but limit n tends to infinity probability xn greater than epsilon equal to 0. This is the definition of convergence in probability, that is xn converges in probability to 0. And we know that if convergence in probability takes place, then convergence in distribution will also take place. Hence, xn converges in probability to 0 implies xn converges in distribution to 0. This is the correct option. Now for the last option, supremum n greater than equal to 1, variance of xn is less than infinity. This condition actually implies boundedness. Now consider pn equal to lambda by n, then variance equal to what? N into pn into 1 by 1 minus pn, which is, if we take n tends to infinity, then it tends to lambda. Again, it is not converging to 0. Thus, option C is the correct one. I hope this solution is clear, and if not, please comment it out. And thank you for watching. Hare Krishna and best of luck for the exam.